Hey everyone, so in this video today we are talk about that system design of Uber, Ola, like that application. So Uber, Ola, so these are the applications getting hassle-free transportation service, right? But it looks like really simple, but at the back end it's a gigantic application actually, which have hundreds of software engineers and working on them, and there is more complex architecture and these are the more complex architecture. Lot of companies join together and internally providing that lot of components and providing that riding services all over the world actually. So if you take that designing of Uber or Ola or Lyft, it's a quite common questions in that all that common architecture interviews actually. So at the time lot of candidates don't know about that how to we need to answer it for that architecture actually. So this video for you, and so in that video I'll be explaining that complete architecture with the end to end and all the programmatical and yeah, error handling, so all those things I'll be explaining in that video, so don't skip that. And let's dive into that. All right. So let's talk about the challenges, the first part actually. So one of the main tasks of Uber or Ola services to match the rider with the cabs actually. So which means two different services in our architecture. So one is for supply service for cab, another one is for demand service for riders actually. So Uber has basically it's a dispatch system. So let me first note it out that supply service and the demand service for both actually. Yeah, so same it is supply service for cabs and demand service for riders actually. So Uber Ola has basically it's a dispatch system actually. So let me clear it out, and so you will get some understand. So dispatch system. So the dispatch system, it's also called as disco, like that actually. So it's architecture to match supply with the demand actually. So the dispatch system uses that mobile phones. It takes that responsibility to match the drivers and with the cabs actually, that's supply to demand actually. So this is the challenges we are going to face, and that next part, uh, how dispatch system will work actually. So basically, dispatch system, Disco, right? So Disco must have these goals actually. That first thing, so I can just put it over there. So in the Disco, so the first point, reduce extra driving, and minimum waiting time, minimum wait time, and minimum ETA actually, estimated arrival time actually. So these are the major three things how the dispatch system will work. So the dispatch system completely will works on maps and location data actually, like GPS. So the GPS will return that latitude and longitude actually. So the first thing which is important to our model, so maps and location data actually. So in that location data, Earth has already you know that it's a spherical shape. So it's very difficult to summarization and approximation by using the latitude and latitude actually. To solve that this problem, Uber and Ola they use that generally they uses that Google S2 library actually. So Google S2 library. So the Google S2 library divide that map data into a tiny cells like 2 kilometer or 5 kilometers, like that actually, and it will give that some unique ID to the each cell. So that means the each kilometer or each distance. This is the easiest way to spread the data to the distributed system and store it easily, obviously. So S2 library gives that coverage for any given shape easily. Suppose you want to figure out that all the supply available within the 3 kilometer range of the radius of city, using this S2 library, you can draw the circle of 3 kilometer radius, and it will be filter out that all the cells. And this is the way to easily to riders to find that driver actually. So you can easily to find out the number of cars in the particular region actually. So if you have your if you have your one 2 kilometer radius, and rider should rider will have that data actually. So rider will start the app, and it's searching actually, searching that supply actually. So in that supply, so that our Google S2 automatically will take, and it will be searching actually. So that algorithm will apply to over there, and it will be returning that id of that cab drivers actually. So this is how it will be get work actually. And that supply service, and how it is works. So coming to the next part, supply services, and that way of working actually. So in our case, cabs are the supply services. So they will be tracked by the geolocation, by the latitude and longitude. So all the active cabs keep sending that location to server every 4 seconds. So let me make a diagram. So these are the our cabs. So all the cabs via that application, like captain application for Uber or Ola. So it will be connecting with our server, and sending that geolocation, like latitude and longitude. So this is for every 4 seconds. So these are the accurate GPS information via that web application server or mobile application to send that GPS location to server for every 4 seconds actually. Here we use that Apache Kafka. So there is another new entry actually. So because we can't send the directly that geolocation to server, using some layer of application, that layer will take care of all the messaging things actually. So there is Apache Kafka, and that Apache Kafka REST API pass that so getting that geolocation data, and Apache Kafka REST API. So Kafka REST API will get the data, and so after that it will go to the Apache Kafka data hub actually. So data hub actually. So that accurate GPS geolocation to send to the data center through that Kafka REST API. Once it passes through that load balancer, here we use that Apache Kafka as a data hub. So once the latest location updated in that Kafka, it slowly passes through that respective worker nodes in the main memory actually. So once all that latitude and longitude, so it will go to the main memory actually. So after that, also that copy of location, that state machine, like latest location of cabs, will send to the database and dispatch the optimization, and keep the latest location will updated. So that's after that the rider will automatically will understand, okay, the cab it's nearly coming actually. So like that. So we also need to track a few more things, such a number of seats and the presence of car seats for children, and the type of vehicle, and the can wheelchair can be fit or not, and allocation. So all those things we will send along with the GPS location actually. So this is some very basic layer actually. And the next part so in that part we will see that supply services and the way of working. That next part we will look into that demand service and the way of working actually. So in that part, demand service will receive that request from the cab actually, and through the WebSocket. So in that part, we use that Node.js. So in that Node.js WebSocket, we're using actually. So once GPS location is sent, so after that it tracks the GPS location of the user, and it also received that different kind of requirements, such as number of seats, type of car, and or pool car, like that. So that demands gives the location cell id, that user requirement to the supply, and make request for the cabs actually. So and that next thing, how dispatch system match to the riders to drive. So we have discussed that disco divides to the map into the tiny cells, with a unique ID with the help of Google S2 service, right? So this ID is used to the sharding key in Disco. When supply receives the request from the demand location, gets updated using this shell ID and a shared key. So these tiny cells or responsibilities will divided into a different server and multiple regions. For example, we can allocate that responsibility of 12 tiny cells with the six different servers and aligning with the six different region actually. So or let me put some diagram in that part actually. So I have an supply along with the demand. So that means the user. So all those it will go to the Disco. So in that I'm going to send that yeah, I'm going to just split that, and I'm going to send that search first the demand level. I can search the supplies. So in that I have a multiple geolocation actually. So for example, geo 1 and geo 2 and geo 3, geo 4, geo 5, geo 6 and geo 7. So like that I'll just create it, and so in that part, so as you can see that so so this is some very basic example actually. So supply sends the request to the specific server and specific server based GPS location data. So after that, system draws the circle and filter out that all the nearby cabs actually. So it will be finding that all the nearby cabs with that demand actually. So once user standing over there, so that nearby all the geolocation will be called, and nearby all the cabs will be captured actually based on that IP, latitude actually. And after that, a list of cab driver will send to the ETA to calculate the distance between the rider and the cab, and not geographically, but a road by that system actually. Because in that road level, we can able to get that some traffic and road diversion like that actually. So that's why we will calculate that ETA and not geographically road system, and after that. We will allocate that cell ID. So this is how it will be get work actually. And so once supply is founded, it will be automatically updated to the demand thing actually. So this is how this thing will work. And the next part, this system, how it will be get scalable actually. So this dispatch system, including that supply, demand, and the WebSocket, is an inbuilt on Node.js actually. So that scalable level Node.js will play that lead role. So let me show. So Node.js is a asynchronous event-based framework that allows that send and receive messages through the WebSockets. You already know that, right? So Uber and Ola uses that open source that called Ring Pop. Uh, So ring pop to make the application cooperative and scalable for heavy traffic. And the ring pop has mainly three parts actually. It performs the below operation to scale the dispatch system actually, and it maintains the consist hashing to assign the work across the workers. It helps that sharing applications so way of scalable and fault tolerant actually. And ring pop-up will use that RPC actually. So that ring pop will use that RPC, so that called remote procedure call protocol. So makes calls from one server to another server, and a ring pop-up allows to using that swim actually. So swim membership protocol or gossip protocol that allows, so swim and gossip actually. So it will be okay that it will be independent workers discover that each other responsibilities, and this way server node who know that responsibility and worker of another nodes actually. And the next part, how does Uber or Ola defines the map region. So before launching the new operation in the new area, so Uber or Ola, any other, so with a new region, so that they are analyzing with the map technology stack actually. So in the map region, we define that various sub region labeled with the okay, this 90 percentage of Uber get traffics covered with the sub region, and that called grade A, and grade B will covers that suburban areas and rural, which are less populated and less traveled by the Uber customer. And grade AB with the union of both sub-region and C covers to that highway corridors connecting with the Uber territories actually. So this is how that region will it get works. And that next part, mapping thing actually. So build the map. So the Uber using that map box. So Mapbox service. So but later so initially Uber was used to that Mapbox service, and later it will be switching to that Google Map actually, Google Maps API for accuracy actually. So Google Map APIs to track the location and calculate that ETAs actually. So using that Google Map APIs, already you know that it will give the trace coverage and preferred access point accuracy, and ETA calculation, and so these are things it will be get support already predefined databases it will have. So we don't need to worry about that. So all those things Google Map will take care of that, to the navigation, so all those things actually. And the main thing, so that workaround level, so we already covered that most of the backend things. And the next thing, that analytics actually. So how many users were using like that actually, to optimize the system, minimize the cost of the operation, to better customer experience for Uber or Ola. And that log collection is very much important actually. So in that, we have your data from the user data for both drivers and the riders actually. So Uber or Ola, mostly they are using that multiple Kafka clusters actually. As you can see that, so that data, they will use that Kafka and Kafka clusters actually. So once the data archived into the, all the data will comes to the Kafka clusters. So automatically the next stage should be a archiving process actually. So in that, all the archiving data will go to the Hadoop cluster actually, like big data. Yeah, obviously Hadoop cluster actually. So after that, Kafka cluster will get expired, and the data index also to the Elasticsearch for the searching and visualization to the other end actually. And Elasticsearch does some log analysis using Kibana and Grafana, and some of the analysis will performed by the Uber using some different tools framework actually. So that are track HTTP APIs, and managing the profile, and collecting that feedback and rating, and promotion and coupons and fraud detection and payment fraud, and incentive abuse by the driver, and compromised accounts by hackers. So this compromised accounts by hackers, Uber uses the historical data of customer and some machine learning technique, and they tackle this problem actually. And that next thing, I'll be show about that complete architecture of that Uber thing actually. So let me show. Okay, so first, we have a driver, right? So driver means supply. So in that part, I can put supply along with demand, that called rider. So these are the things you already know will go to the uh, web application framework. Okay, so that called WAF. So web application framework or mobile app like that, and it will be go to the load balancer. So load balancer will manage the loading of capacity, so all those things actually. And so in that, all those things will be get split actually. So so in that part, HTTP REST services play the lead role. HTTP read, and Kafka REST actually. And also we have a web socket WebSocket node actually. So once we get the data, so that Kafka REST API will pass the data to this Kafka. So the Kafka data load actually. So from the Kafka, it will be go to the Hadoop and ML fraud detection and ETA calculation and pricing and Spark and analytics, all those things actually. And WebSocket thing. Okay, so the WebSocket thing will go to the Disco and supply and demand. So if demand user uses the application, the data will go to the supply. If supply uses the application, the data will go to the demand. So all the data will get keep sync actually with each other. So in that part, so the so the Disco, all the data will go to the region wise, and the region one, and region two, and the region three, and the region four, and the region five, so like that. So Google S2 service will automatically get each data things. So in that part, so automatically if it will checking that each location ETAs actually, so how much ETA will it get there. So after that, supply also will check. That means it all with interconnected actually. So oops, sorry, so it's all with interconnected demand. So it's all with interconnected, and region 1 and region 2. So that diagram looks slightly messed up, but you can get understand, I hope actually. So okay, so this is one. And so after that, it will be checking that analytics part actually. So that first thing, it will be go to the archive data, Hadoop Hive actually. And that next part, fraud detection. Fraud detection using some ML technique, and ETA calculation. So these are the terms I'm already explained in that same video. You can just go through again actually. So ETA calculation, and the next part, Apache Spark for the keeping the logs, and that final thing, ELK Elasticsearch, and Kibana. So for the visualizing the data actually. So all the these complete so all the data will take the backup actually. So every 1 hour, so that backup data center, so it's real time backup thing actually. So in worst case, so if anything servers crash or something, there is a problem between the production, so immediately that backup will be get restored actually. So this is why, that's why that all the things will be get synced with the backup data center actually. And also they use that RDBMS actually. So RDBMS. So in that RDBMS, will take that all the traces from the Disco supply demand from that actually. And also it will be keep getting that all the region logs. So all the region logs will store to the Kafka, and it send it to the again that ELK and Kibana. So that means Elasticsearch and Kibana for the log analyzing actually. So this is how, and these three will get keep synced, and this Kafka will get keep synced actually. So as you can understand that once supply and the demand started to using on that, it will be go to the web application framework, and the next part to the load balancer, and it will be going to the this module, that single layer thing actually. So in that there is a three APIs there: Kafka REST API, HTTP REST API, and WebSocket node actually. So once we get that information from that user end, so automatically it will be sending that Disco supply demand, and it will be sending that Google S2 service. The Google S2 service will check all the regions of data, and it will be sending that nearby that cab details and nearby the riders details to the respective team members actually. At the same time, these are the details will send it to the Hadoop and the fraud detection and the Spark, ELK, Kibana. So all those things will be sent, and it will be analyzing that At the same time, all the traces will be get to be storing in the RDBMS database, and also region all the region things will be getting the logs, and the logs will be go to the Kafka, and the Kafka details will be go to the ELK and the Kibana, so the log visualization. And after that, as you can see that, so that uh, dashboards and the pie charts, as you can find out that actually. So that backup data center, it's all about that micro data service actually, micro data services actually. So for your information actually. So this is how that Uber and Ola will it get works actually. So hope you guys from this video you will get some knowledge about that, how the backend will run behind the Uber and the Ola and the Lyft. Those are the gigantic application actually. So building that application is easy, but building a complex algorithm with a that scalable application, it's a pretty much hard actually. So try to understand that, and you can just go through that video again. You will get some knowledge about that. And so hope you guys you will really like that video, and please subscribe my channel, and don't forget to like and share. We hope you found this video informative and helpful. If you did, please hit the like button and consider to subscribe our channel for more videos like this in the future. Also, don't forget to share this video with your friends and colleagues who might find it useful. If you have any questions or comments, please leave them in the comment section below, and we'll be happy to respond. Thank you for watching. We'll see you on the next video.